Okay, so here's a problem. We got a fixed connection here at A, fixed connection at B between AB and BC, and a free end here at C. We have this horizontal distributed load along the left side and a 10 kip vertical force. And we want to find the vertical displacement at C. So I'm going to have to first find the real moments in this system and then the virtual moments in the system. What's that?
It's like hangman.
Oh. That's not the right answer, so you get another add an arm to it. Isn't that the way it works, hangman? As you don't get it right, your man appears before your eyes? I can't remember. I never liked that game. Yeah. Yeah, it's a gallows. You can think of it that way if that makes you feel better. We're designing a gallows. All right. So what I'm going to do is we're going to first find the real moments in the system. So let's start with something in AB. So I'm going to cut the structure somewhere here in AB, and you have to decide whether you want to work the bottom part or the top part. Well, I'm not interested right now in finding reactions. I'm trying to be as efficient as possible. So I'm actually going to work this top section because I don't have to find any reactions. And to make it easier on myself, I'm going to set my coordinate system to start at the top and go down. Okay? So for this particular section, my free body diagram will look like this. So I'll have the 10 kip force. I'll have a portion of this distributed load. Remember, it's 0.5 kips per foot. And I'm going to assume it varies down this way, and I'll call that Y. Okay? And then what I'll assume is that it has a response with a moment in AB that looks like that. We're not going to worry about shear. We're not going to worry about axial force right now. We're just going to do bending. So I now want to find the moment as a function of Y in this section AB. So, like we've done many times before, I'll get a concentrated equivalent force to that. And what would that force be? Well, it's a rectangular shape for the load, and we know that it's base times height, so our base would be Y, and our height would be 0.5. So that force is going to be Y over 2, right? A half. So now when I sum moments, at the cut, what do I get? Well, I'm using right-hand rule. This assumed moment I have here is negative. About the cut, how does this equivalent force, what kind of moment does it create? Positive or negative? Negative. So it would have a force of Y over 2 times a moment arm of Y over 2. Right? So this is the force. This is the distance. And then don't forget our 10 kip force out here, which also creates negative moment. And what's its moment arm? I forgot. This is 10 feet. So it'd be 10 feet. So I can now solve for my moment in AB. And it looks like it's negative Y squared over 4 minus 100. And that would have units of kip feet. Okay? Now what do? Well, I want the real moment somewhere in BC. So you want to work the left side or the right side? Right side. So I'll now draw a little free body diagram for that. And also, to make it easier for me, I'm going to assume my unit goes from right to left. I'll call that x1. And I'm interested in the real moment that creates in BC. So again, I will sum moments at the cut and make sure that's in equilibrium. So my real moment is negative in this sign convention. And about the cut, this 10 kip force also creates negative moment. And it'll be 10 kips times a distance of x1. So it looks like my moment in BC is equal to negative 10 x1. And that would be also units of kip feet.
Why do you say x1 like that?
Well, you know, when you do x, you're always thinking of going from right to left. That's the typical Cartesian coordinate. So I want just to indicate that I'm going in a different direction. I probably should have made this y1 because normally y is up. In fact, I think I will. Should I do that now and mess you up? Go back and put ones? Does that make you feel better?
Yes.
Okay. So I'll call that y1. So the force will be y1. This will be y1, y1, y1. That was easy fix. We've run out of time, but I've got the real moments. What would I do next?
The virtual one.
I do the virtual moment. So I will draw this. So the virtual system is going to look like this. So it's the same geometry. Maybe I didn't get them quite to the same scale. A, B, C. But now I'm going to come along and assume a virtual load of 1 at C down. So I'm assuming that C is going to move down. And I have to go back and use these same free bodies with the same assumed coordinate systems and find the virtual moments for those. And then multiply them together and add them up. So what I'll do when we get back on Thursday is I'll just finish this problem real quick, and then we'll go on and do the SAP 2000 modeling for Project 2. So don't forget to bring your laptops. All right.